Hello, my name is Mario, and I will speak a little bit about the paper Method for Sizing and Selection of the Battery for the Energy Storage System of an Electrical Vehicle. The paper was developed by me, Mario Jr., and also the professors Flávio Gomes, Ítalo da Silva, and Marcelo Araújo. So, the process of replacing conventional solutions of mobility by electrical vehicles have gained more and more investment in the last years and also a lot of policies in the entire world. And one of the main study topics of electrical vehicle and the main research point is the battery-based energy storage system. So one of the main topics is how to choose the best cell and how to size a BESS. And based on that information, we do our work. So if I have the vehicle parameters, how can I size the battery pack and define the best cells? So to answer that question, the first thing we have to do is the estimation of the amount of energy. So we basically did a dynamic model from a vehicle, and based on that, we can estimate the amount of energy. So if we have as input the mass of the vehicle, velocity profile, drag coefficient, the density of the air, and the friction energy that you're gonna need, we can do the sizing. We can start the sizing of the BESS. So first we're gonna need to apply the set of the equation to discover the number of cells that will be in series, the number of parallel strings, the total mass of the pack, and also the volume. So to we found this information about the BESS, we're gonna need as input the nominal voltage of the power inverter of the powertrain system for the vehicle, and also some information from the battery cells, like the nominal voltage, the nominal current, the mass, and the volume of the cells. So here we can notice if I change the battery cell by this changing this characteristic here, I will have a different arrangement for my BESS. So every time I change the battery cell, I will have a different arrangement. So how could I choose the best battery cell for my application? So to do that, we use the analytic hierarchy process. So the AHP is one of the most used methods when you have the multi-criteria problem. So when I have a lot of solutions for my problem, or more than one solution for my problem, how can I choose which one is the best? So to find the best cell, I have here a multi-criteria problem. And to solve this multi-criteria problem, I will use the analytic hierarchy process, or AHP. The AHP will have as input all the BSS I found, so I can have a lot of BS solutions for my problem. And the analytic hierarchy process, you give to me the best, who is the best solution for my specific problem. So I apply as input of the AHP all the BSS I found, and he's gonna give to me which one is the best BSS. So here I have a quick review of the algorithm. So basically, first I have to estimate the amount of energy based on the vehicle parameters in a dynamic model of the vehicles. Have the amount of energy and electrical information from the battery cells. I can size the pack for each battery cells, and after that I will apply the AHP method, and here gonna give to me a list of the best cells. So I have as output which one's the best cell and which one's the best BESS for my application. As a state of case, we use a SI electric formula vehicle, and the vehicle's parameters is two. So using the solutions found in AHP, we get as output the BSS number 60 is the best one for us. So they have the total of 22 serial cells and 4 parallel strings. The mass is 37 kilogram, and the volume of the battery package is 11.6 liters. So the output of the step is basically that table here. that was also taken direct from the paper, and we see that they gave us the model and the score of that model. So the more close the score is to one, the best is that option. And just to conclude, to conclusion of the that video, we found a method developed for sizing and selection of the battery of the electric vehicle, importance of attaining the specific demands of energy consumption and how to take into account the energy consumption in the sizing of the battery package. And we also found a method that assists us in the decision making about the type of the battery cells to be chosen. So that's it. Thank you.